The next demonstration that we are going to perform is on the medium range UT lamp technique. For this demonstration, we will use a 10-inch pipe, schedule 40, with a coat of paint, and we are simulating a microbiologically induced corrosion on two parts of the pipe. So they are just basically pits being put on the 10-inch pipe itself. So the first thing that I need to do is to connect the sensors. And let's take a look at the NDT web. First, we need to go to the pipes and tubes application, medium range UT lamp, and start. So again, I've created a project known as webinar, but for the purpose of this demonstration, I will create a new pipe. We know that the pipe is 2 meters long, so 2000 millimeter. It has a paint. And the pipe size is 10-inch, schedule 40. And as you can see, the thickness and the circumferential length changed automatically by the software itself. We also need to add in a datum. And for this, I just assume that this short pipe, the datum is located right in the beginning of the pipe itself. The next thing that we need to do is to select the tool. For the medium range UT application in VOLTA, it can provide many different kinds of application, including pulse echo circumferential shear horizontal technique, pulse echo circumferential lamp technique, pulse echo axial lamp technique, and for this particular demonstration, it's pitch catch axial lamp technique. And we have actually tested this lamp technique on this pipe, and we found out that option 3, which is using the S1 wave mode, is the best wave mode to generate results. So we are going to put in the tuning module as recommended by the software. This tuning module and coils are recommended based on the thickness of the material previously selected. So the coils have been put into the sensor itself. So a very strong magnet, so watch your hands. Center frequency here is 548 kilohertz, but as we can see later on during the test scan or the frequency sweep, we will see that the S1 mode is actually very close to the A1 mode around this frequency. So we are actually generating both wave modes at the same time. But let's update the software, select the test location, and we can see that we are going to start at the beginning of the pipe. The range is right, and we will scan 2 meters along the pipe. So this is all good. Moving on to the test scan, looking at the NDT panel, making sure that all parameters are correct. The gain is okay. Number of cycles is good. Filters, we have low noise filters. We put in a high bandpass filter in order to eliminate different kinds of wave modes. And let's run. We can also actually change the trigger type, whether or not we use an internal trigger or we use the encoder of the sensor itself. For this particular webinar, we are just going to use an internal trigger. Running the frequency sweep, we can see that the A1 mode is actually appearing around 500 kilohertz right up to around 570 kilohertz. So between 450 to 570 kilohertz. And the S1 mode is actually appearing between 500 and 650. So we can see that the A1 mode is actually much stronger than the S1 mode, in fact. So this frequency sweep is actually a very useful tool for the medium range UT lamp technique, because it allows us to select the best wave mode. And I'm going to select at 500 kilohertz, roughly, approximately. Save it, and move on to the scan mode. Again, making sure that everything is good. So this technique is actually using the MRUT lamp pitch catch, and the sensor is moving axially down the pipe. So when we move the sensors axially down the pipe, this wave that is generated is actually traveling circumferentially along the pipe. So when it does that, we have two forms of amplitude that appears. One is on the short path, and one is on the longer path. So if we want to see the longer path, let's increase the range. Let's make sure that this even number 500, and let's making sure that all settings are good. Let's run the scan. So this is actually the long path, and this is the short path. This is actually the tail end of the beginning of the S1 mode, and this is actually a strong reflection from the A1 mode. So this is the short path, and these are the long path. Moving along, you can see that there is no impact on the short path, and once we reach the corrosion, the short path is completely attenuated. Again, no reflection because there is no corrosion between these two corrosion sections, and it's attenuated again. As with the surface wave presentation, we can actually create a strip chart based on this gated gate 2, and you can see the dip coming up back again, and when there is a corrosion, there's another dip and coming back up again as I move backwards. So this demonstration clearly shows that the effectiveness of MRUT lamp technique on corrosion that is located right on top of a pipe support. MRUT lamp technique is actually very useful when when we have a pipe that is accessible from the top, so we can make a quick inspection for such pipe corrosion under pipe support, as an example, especially when the inspection can be done from the top.